Good afternoon. My name is Ravi Babu, Assistant Professor in IARE College. Today we are going to sing in Model 2 System Response. In Model 2, we are going to sing on the pulse transfer function of the system with a zero order circuit. In yesterday class, we will see the pulse transfer function definition and pulse transfer function properties. After that one, we see the pulse transfer function for a forward path, that is open loop control system, and pulse transfer function for a feedback path with a unity feedback, that is closed loop control system with unity feedback for the pulse transfer function, and some of the problems we see in block diagram in pulse transfer function. Today I am going to taking the pulse transfer function with a zero order code device, that is, see the circuit diagram, whereas here I am taking the one system with respect to, that is G of S, that is here I am taking the open loop control system. In that one, I am using a zero order voter device, where it is in front of the system response, So I am taking the zero order vote device with respect to the pulse transfer function, that is y of z by r of z, where I am giving the pulse with before the zero order device. That's why in the function we are not getting the g into h of naught. For s, we are not getting the z function. Okay, why? Because we are giving the pulse to this function. That is g h naught is only coming. In place of s, we are not getting the z. So we are getting the pulse. That's why. So here we are using the g of s is nothing but it is coming to as g of z. So we will see the previous section. How can you find the transfer function of the pulse transfer function? Nothing but first you have to apply the z transform. After that one, apply the Laplace transform. We can get the, after that one, you apply the inverse z transform. We get the pulse transfer function. This is order way I am going to applying for this function. That is the function with respect to g of s. Only system is with series with first order whole device. That is g h naught of s. For that total function, I am applying z transform. Okay, we know the previous sections, that is the for zero order whole device. For zero order whole device, the output of this function is, that is 1 minus e power of minus st by s. This is your zero order whole device output function. So into g of s. Only this term is coming to as this one. Okay, we see this one is in previous sections. After that one, I am going to multiplying this g of s into total term. So 1 by s into g of s minus e power of minus st by s into g of s. E power of st by minus s into g of s. We are getting this one. Okay. Coming for next. In the previous here, we are having the z transform. We have to apply for first function and second function, e function also, exponential function. Coming for here, I am taking g of s by s is I am taking the g1 of s. Okay, so for this one, if you apply inverse Laplace transform. Okay, what I am saying, already in previous section we see the steps for finding the pulse transfer function. First apply z transform, after that one apply the inverse Laplace transform. After that one apply again z transform. Okay, so inverse Laplace transform of g of s by s. What is the first term? G of s by s. No, for this one inverse Laplace transform is g1 of s. Okay, so I am taking here g of s is the g1 of g of s is coming to g1. Okay, so it is g1 of t. Coming from the second term here, it is a second term. It is the first term. For this one, g1 of t. Okay, and coming for this one, second term. For second term, what is inverse Laplace transform? G1 of, it is exponential function. That is exponential with the unit of delay. That's why it is coming to g1 of t minus tau. It is coming to like this. So for this one, I am applying a z transform. If you take z transform of the first term, that is, it is coming to as kt of t is coming to as kt, no? So kt of tau. If you take the common t common, So G1 of k minus 1 into tau. So it is coming to as Z inverse of G1 of into G of Z. G of Z. We know this one. What is G1 of Z? Already we see this one. This is G1 of Z. Okay. That is G of S by G of S. G of S by G of S. So finally we got the exponential term is Z inverse of Z transform of G1 of S by G of S by S. We got this one. Okay. Substitute these two values. So what we are getting for first term value G1 of Z. First term value G1 of Z. G1 of Z. For second term value Z inverse of G1 of Z. Z inverse of G1 of Z. If you take here in this function G1 of Z is common. So 1 minus Z inverse of G1 of Z is creating. Okay. So therefore the pulse transfer function of the with zero order whole device. Okay. Zero order whole device is 1 minus Z inverse of G1 of Z. G1 of Z. It is your pulse transfer function of the function of open loop control system for in case of the discrete time control system for with zero order whole device. Zero order whole device. Okay. What is the value of this one? Z inverse of 1 minus Z inverse of G1 of Z. 1 minus Z inverse of G1 of Z. Okay, G1 of Z. That is nothing but what is the G1 of Z? G1 of Z is nothing but G of S by S. Okay, this is what pulse transfer function of the open loop control system, open loop system with of the zero order whole device. Zero order whole device. Coming for the next problem, here I am taking the G of S is function is I am going to changing here. I am giving the sum of the value, that is 1 by S plus 1 I am taking G of S value. Okay, G of S value I am taking this one. Find the pulse transfer function of this one. Okay, pulse transfer function of this one. So what is the basic formula in previous section we see now? What is the pulse transfer function of the system with respect to zero order whole device where the pulse function is given to the forward to the zero order whole device. That is the formula for this one is 1 minus Z inverse of G of S by S. Okay, G of S by S. Okay, so substitute these values here. Okay, 1 minus. So 1 minus Z inverse nothing but Z minus 1 by 1 minus Z minus nothing but Z minus 1 by Z into G of S by S. What is the function they given? G of S by S. So what is G of S is function? 1 by S plus 1. 1 by S plus 1 into S. So you have to compulsory when the problems is coming from like this. You have to remember the first concept. First 3 part concept. Formula. Okay. This is the formula you have to remember. Where G of S is given 1 by S. So substitute this one. After that one. In this function. In the inner function. It is coming to as 1 by. I want to find the Z transform of this one. So 1 by S into S plus 1. So take the path of fractions. What happened? A by 1 by this part is coming to as that is 1 by S into S plus 1. Take the path of fraction nothing but what? A by S plus B by S plus 1. B by S plus 1. If you want A value first. So first write the total function 1 by S into S plus 1 into below the A value how much value? S. Where S equal to 0. This part equal to 0. You do. Okay. If you submit this one, we got the A value is 1. A value is 1. We got it. Okay. We got it. The A value is 1. Yes. Coming for the B value. Okay. Coming for the B value. What is the B value? 1 by S into S plus 1 into B value denominator part is S plus 1. Okay. And where take this one equal to 0. That is S equal to minus 1 value. Okay. So what happened? And this one cancelled. S equal to minus 1. So what is the value of this one? Minus 1. We got the minus 1. Okay. Substitute this one values here. A value is 1. B value is minus 1. Okay. And substituting this value in the equation. We got this equation. What we have to do next one? We have to do, it is going to Z is inside now. So Z is inside Z by Z minus 1. Okay, minus Z by Z minus half e power of minus t. Okay, so it is coming to as, if you multiply this one into here, so what happened? Z will cancel, Z minus 1 will cancel. That is 1. Okay, next. If you multiply inside the 1, so Z cancel, this one and this one is cancelled. Okay, so it is coming to as Z minus 1 by Z into e power of minus t. Okay, if you take t value is 1, okay, for natural functions, frequencies, so it is coming to as e power of minus 1. So 1 by e. That value is 0.3679. 0.3679. Okay, we have to remember this one value every time in examination section also. Okay, so e power of minus tau, I am taking the one, it is 0.3679 value. Okay, 79 value. So if you solve this one, cross multiplications, we got the 0.6321 by Z minus 0.3679 value. Okay, after that one, so we are going for the step response. Okay, this is a transfer function. This is your transfer function. But in a problem, they given as determine the pulse transfer function and the step response of the system is this one. They given step response. That is in the input section side. Here we are getting the step response. Okay, here we are getting the step response. Okay, here I am giving the step response. That is nothing but the R of Z's value is step response. So what happened? Y of Z equal to R of Z into R of Z. This Z value is coming to inside now here. So what happens? Step nothing but it is Z by Z minus 1. Again, Z by Z minus 1. Okay, so Z by Z minus 1. If you solve these mathematical calculations, that is Z by Z minus 1 into Z by Z minus 1 by Z minus 0.361. Okay, okay, into this value. Into this value. Okay, so what is this one? This is your step response value. So y of Z equal what happened? Last final answer Z by Z minus 1 minus Z by Z minus 0.74. Z by Z minus 0.74. Okay, so this is a value for this one. Just two. This is your final, before the final equation, this is equation of for this one into step response. That is a value. This value. Okay. Into this is your step response. So solving this one, we got the Z by Z minus 1 minus Z by Z minus 0.3679. 3679. Okay. 3679. After that one, I am going for taking the inverse Laplace. That is, Z transform is converted into discrete time functions. Z transform is converted into discrete time functions. That is, y of k equal to 1 minus, this value is coming to 1 minus, this value is 0.3679 whole power of k. Whole power of k. This now is the formula again. It is also will be formula. Okay. Next. So we complete the pulse transfer function of this system with respect to the function is g of s equal to 1 by 1 minus s. 1 by 1 minus s. Now I am going for another one. Another one. That is, here the pulse transfer function I am going to determining for the function of, for the g of s. This g of s value is, this g of s value is 1 by s plus 2. Okay, previous formula is s plus 1. Okay, again here the given time section also t equal 1 seconds. T equal to 1 seconds. And the previous section also they give now t equal 1 seconds. And they are using here feedback section with negative feedback. Remember, with negative feedback. Okay, once again I am repeating. I am giving the input is step response. Input is step response, and the given time is t equal to 1 second, and the forward path function, okay, that is represented as g of s. That value is 1 by s plus 2 with unity feedback they given, and that feedback is negative feedback, and the feedback is negative feedback. So what happened? That is, the pulse transfer function is here. It is y of z. Not written here. It is y of z. Okay, y of z by r of z equal to forward path gains. That is g into h naught of into g into h of z. So why here is coming to z, here not is coming nothing but because of this pulse. Because of the pulse. There is no possibility for the S plane. When the problem is coming to in S plane, that is nothing but G order device is in S plane. Okay, the pulse of this system is going to be only the numerical values G, H naught. Okay, this is the data the given. Okay, so what happened in the pulse transfer function? This is y of z by r of z. R of z, first forward path G H naught of S. So H naught of S is not coming now. Okay, G H naught into G of Z by 1 plus G into H naught into G of Z. G of Z. Okay, this is Okay, with negative feedback, the pulse transfer function is this one. Next. So this is the first function. What is the formula for generally for zero order volt device with you? Here in the problem there is a unity feedback. But what's the general formula for forward path pulse transfer function formula? One again I am recalling. 1 minus z inverse of z into 1 by s into 1 by s plus 1. 1 by s plus 1. Why s plus 1? Sorry, it is s plus 2. It is s plus 2. It is s plus 2. Why it is? The function is given as g of s equal to 1 by s plus 2. Okay, 1 by s plus 2. Now, taking this one, calculation part. 1 minus z inverse is nothing but z minus 1 by z into 1 by. This part is coming to how can you write? That is a by s in plus bs by b by s plus 2. S plus 2. Okay. Next, same fraction. Take for this one is partial fractions. That is 1 by s into s plus 1 equal to a by s plus b by s1. If you want a value, okay, sorry, a value no, it is coming to only s, where s equal to 0. What happened? This one is cancelled, equal to 1. Sorry, s equal to 0 na? It is s plus 2 now, sorry. It is s plus 2. S plus 2. Okay, it is s plus 2. So s equal to 0, 1 by 2. That equal to 0.5. That equal to 0.5. Next, coming for b value. What is the b value? B value is 1 by s into s plus 2 into s plus 2, where s equal to minus 2, cancel, that equal to s equal to minus 2 now, 1 by 2 into minus 2 plus 2. Okay, so it is value is it is coming to 0. Total value is, if you substitute this one, we got it, g of s into this value g1 of s, g minus 1 into z into 0.5 by s plus 0.5 by s plus 2. Okay, if you take 0.5 is common, so what happened? Z minus, if you multiply this one into inside, we got in this one. Okay, we got this one. Next one is for solution only, mathematical solution. 0.5 is common now. Okay, 0.5 is common. So 0.5 if you take common, what are mathematical expressions? Okay, so we multiplied that one inside. What happened? This one cancel, 1 is cancel, 1 by z is coming. Okay, and 1 is coming. Next one is z minus e power of minus t. This one. So it is coming to as z by z minus 1 by z minus 0.1353. Okay, 1353. If you do this for mathematical calculations, okay, 0.5 into, if you take LCM and after answer, we got it this one. Okay, after that one, what is your function? Pulse transfer function. It is only for forward path G into H naught into G of Z. Okay, you have a feedback path also with unity feedback. So 0.43235 by Z minus 0.1353 by 1. What is the feedback here? Negative feedback. Plus this function, okay, into 1. H of is equal to 1 now. H of is equal to 1. If you solve this one, we got the answer this one. 0.43225 by Z plus 0.29705. 29705. Okay. So this is a first transfer function for unity feedback system. Okay. Next. In previous section, only pulse transfer function for forward path with some functions they given systems. In this section, I am taking as with function is s by 1 by s plus 2, but the forward path is having the negative feedback. Okay. So this is the value. Now I am taking the reference as Ogata and QBook. You can refer that one also. Thanking you.
Like, share and subscribe. Hit the bell icon for more updates.